Hello everybody, welcome to another video lesson. Today we are wrapping up our chapter on trigonometric functions. We are going to look at graphing horizontal and vertical translations of our trig functions today, specifically sine, cosine, and tangent. So let's hop into our concepts. First off, we've got phase shifts and vertical shifts. Okay, so we have, if we are moving side to side, that is what we call a phase shift. A phase shift, that is what we call our horizontal translations for our trig functions. And if we're moving up and down, we call that a vertical translation or a vertical shift, just the same as we would any other graph. Now we get a phase shift when we have in the argument of our sine or cosine function, okay, when we have a minus h or a plus h. Okay, similar to how we've seen in the past, if this is theta or x or whatever this is, then if I am subtracting from that, I am affecting sort of my domain, not really my domain overall, but my initial domain and my initial starting points, okay? And we'll see what that looks like here. So if I have minus h, then we are shifting h units to the right. And if I have plus h in here in my argument, then we are shifting h units to the left, right? And we've seen also, similarly with k, with previous function shifts, if I have a plus k tacked on to the end of anything, then we are going to shift k units up. And if I have a minus k, we're going to shift k units down. So this is what this looks like for both sine, cosine, and even tangent on here. All right, now for this, our b is going to be going to change our period, right? Now keep in mind my b is actually outside of this argument right here for my sine and cosine, and tangent really. Okay, so this whole thing would be inside, let me erase that and get that a little bit better. This whole thing would be inside my sine, okay? And just the b theta would be inside the sine and cosine and any of the other trig functions inside of my trig function. It's tacked on, while my h values and my phase shifts happen inside of this sine and cosine functions, okay? So you can think of that as having some extra parentheses around there, if that helps. All right, so just general transformations and what these look like, okay, we have four things to consider. We have amplitude, and I'm just going to work over here on this left-hand one. We have amplitude, that's our a value. It's the coefficient out in front of our sine, cosine, or tangent. We have the period change, which happens with this value b. And again, we can think of this as having these parentheses right here. Okay, so this is going to be inside of my cosine. So the period happens with b, and then we have a phase shift with h, and a vertical shift with k. Now, all of these can happen at the same time, so we're going to have a lot of transformations going on. So our keys to success here, what we're going to do, we are going to determine first the amplitude and period of our function, okay? Then we can start with the intersection of our midline and our vertical axis. That is what we think of kind of as our starting point, right? And then any phase shift or vertical shift that we have is going to move that intersection. Okay, so think of it as moving just one point around my graph, and then we can graph our functions using the exact same techniques that we've used previously. So let's go ahead and get into some examples. We're going to have 5 examples in this video, so it might go a little bit longer, but let's see how we can get this done. So first example, we're going to graph a 3 sine 2 theta minus pi over 2. And we're going to graph this on the interval from 0 to 2 pi. Okay, so keep in mind if you're asked to graph on a certain interval, what that interval is. So let's take a look first at our amplitude. That's going to be 3. That's an easy one to find. Our period is another easy one to find. Again, that's just going to be 2 pi over b, which is going to be pi in this case because our b is 2. Now our phase shift, we can see we have a minus pi over 2, which means we are going to shift this thing to the right pi over 2 units. Okay. Now I have to tell you guys that we really need to be good at just understanding the parent functions and what those look like. Okay. I need to understand what sine theta, what sine x, what cosine x, what tangent x looks like, just the parent functions. Okay, because this is going to be critical for us kind of picturing in our head as we move these around our graphs with transformations. So I should know that this is what sine theta looks like. Okay, I'm going to start here at my origin, go up first, come back down, and then end here. So my period for the parent function would be our 2 pi, right? And then I'm going to have 3 midline intercepts within that parent function. All right, so let's go ahead then and start graphing just this function without the phase shift, okay? Because we can pretty easily graph our function with just a change in amplitude and period, right? And we do that by, again, starting at our origin. Okay, we're going to go one period length, that's going to be pi, and then go another period length since we're asked to go to 2 pi. And then at those midpoints is where we have this other midline intercept, right? Okay, and then at the midpoint in between each one of these midline intercepts, we're going to have a maximum and a minimum value. And remember, for sine, we're going to go, as we go to the right, we go up first and then come back down. Okay, up first, then back down for sine. So this is what my reference graph would look like. Now we have our midline here, and we have this intersection between the midline and our y-axis. This is kind of like our starting spot, right? So our midline doesn't change. However, this starting spot, this intersection, is what is moving, and we are going to move it right pi over 2 units. So that's going to shift to the right pi over 2, and we're going to have a new starting point right here at pi over 2, which means that my new period would start from pi over 2 and go, again, it's going to go pi values, okay? It's going to go a distance of pi is a better way to say that. It's going to go a distance of pi. So from pi over 2, distance of pi would get me to 3 pi over 2. So again, at the midpoint, we would have another midline intercept. That's going to be right here. And then in between those, we're going to have our maximum and minimum values. Now, the shape doesn't change from our reference graph here. We are starting here at our starting spot, and we are going up first and then coming back down. Okay, so we can go ahead and plot out all of our maximum and minimum values. Okay, just like so. And then my graph would look something like this once I fill those in, okay? Now, keep in mind, we were asked to graph from 0 to 2 pi, so even though I shifted this way, I got to figure out what the rest of this graph looks like on the left-hand side after I've shifted, okay? And we know that it's just going to continue. It's going to come down and then back up, and it'll end here at my origin again. All right, so that is what my graph would look like in a not-so-great sketch. So let's see, kind of clean it up a little bit. This is what it would look like here. With a little bit of a cleaner graph. All right, let's take a look at another example here. Graphing a cosine function now. We've got 4 cosine 1/2 theta plus 3. Okay, so my amplitude here, amplitude is going to be 4, right? That's just my a value. My period is going to be 2 pi over 1/2. And if you ever get confused with that, remember to just multiply by the reciprocal. So that's going to be 2 pi times 2 over 1, which will be 4 pi. At the vertical shift, we're going to go up 3 units. And again, I just need to think, what does the parent function of cosine look like? That's going to look like this, right? We're starting with the maximum point. We're going all the way down and then back up to our maximum point at 2 pi, which is my parent function's period. And at the halfway point there, we are going to have our minimum. So at pi, we'll have our minimum. And then at the midpoints of each of those, we would have our midline intercepts. So that's our cosine, right? Our amplitude is 4, then we would start up here at 4, and then at 4 pi, since that's my period, we would have another value of 4, and then at negative 4 pi, we'd have another value of 4. And I know in between both of those, all of these points, we're going to have our minimum values of negative 4. Okay, so at 2 and negative 2 pi. And then in between each one of these maximum and minimums, we have our midline intercept. So this is what my reference graph would look like. Okay, and again, my midline at this point is on the horizontal axis, and this is my intersection point that we can think of as what's moving. Okay, so with a vertical shift, my midline is going to move up 3 units. So my midline is now up here. So when my midline was down here on the horizontal axis, we went up 4 units to 4 and down 4 units to negative 4. However, now my midline is at 3, so we're just going to go up 4 units to 7 and down 4 units to negative 1 for my maximum and minimum values. So that's going to change the range of this function. Okay, but the shape does not change now. Okay, since we've graphed the shape accurately here with our reference graph, the shape does not change. So I can go ahead and plot my maximum and minimum values at the same theta values that I did for my reference. So I'll have minimums again at 2 pi and negative 2 pi, and maximums at 4 pi and negative 4 pi. And then those maximums, however, are going to be at 7, and the minimums will be at negative 2, like we said. All right, now from here, we can just go ahead and, at the midpoints, plot our midline. Okay, so in between each max and min, we're going to have a midline intercept. Okay, that's going to be halfway in between each. And we can go ahead and connect all of my plotted points. And this is what my graph would look like. And a little bit cleaner version of that would look something like this. All right, now we're going to graph a tangent graph. Okay, so I've got 2 tangent 1/4 x minus 60 degrees plus 3. So now we're in degrees mode, and we're asked to plot this on negative 300 to 1140 degrees. Okay, so amplitude for tangent, none. Remember, tangent does not have an amplitude. However, it does have a period length, right? That's going to be 180 degrees, or pi, divided by b, which in this case is 1/4. So that's going to be 180 degrees times 4, or 720 degrees. Now my phase shift, we're going to go to the right, because this is minus. We're moving right 60 degrees. And my vertical shift is going to be up 3 units. Okay. So we want to just remember, think about what does the parent function of tangent look like. That's going to start here at the origin. We're going to have a period of pi, so we're going to go to the right pi over 2 and to the left pi over 2, and that's where our vertical asymptotes will sit. And we're going to have this kind of general curve like this. All right, so if that's what that looks like, again, I've got my midline and I've got this sort of intercept here at the origin. I can go ahead and write my vertical asymptotes. We're going to write those at halfway of our, okay? So if my period is 720, then I'm going to go to the right 360 degrees and get a vertical asymptote there, and then to the left 360 degrees, and I get another vertical asymptote there. Okay, but now we have this phase shift. So at this point, we can take into account this phase shift. You got a phase shift of 60 degrees to the right. So I'm going to take each one of these vertical asymptotes, and I'm just going to shift them 60 degrees to the right. So now they're here and here at about, what, 420 and 300 degrees, or negative 300 degrees. So then at the midpoint of this, we would have our sort of our new starting point, right? And our new starting point has moved up 3 units, 1, 2, 3, and over 60 degrees, just like my vertical asymptotes did. So it's going to move up 3 units over 60. That's going to be right about there. And then I can go ahead and just plot that again on each one of my intervals. So I have another, once I go another 720 degrees, I have another vertical asymptote. And again, in between that vertical asymptote and this one at 420, I have another midline intercept here, because my midline has effectively shifted up to 3 units. So then we can, let's get rid of those references, and we're going to create a very small table for our tangent, and I'm just going to pick the midway points here. So I'll go 240 degrees, that'll be right about here somewhere, and then negative 120 degrees. So that's the midway between my starting point and my vertical asymptotes. Okay, that's just the midway points. You don't have to, but that's a pretty good choice for picking your plots, the x values to plot. Okay, so when I do that, I get values of 5 and 1. So I can plot those. It's going to look something like this. And then I can just start to fill in my curve. And once I've done that for one interval, I know it's just going to repeat for all my intervals. So I'm going to plot another point here, plot 2 other points here at 5 and 1, and then fill in that curve that should look just like my first curve. All right, so that, guys, is what our tangent graph with translations and transformations would look like. Let's go ahead and take a look at one more, just for tangent. So I've got, again, the general idea of what tangent looks like. We're going to graph this from 0 to 3 pi over 2. This is our function here. So we've got a period of pi over 2, since my b value is 2. I've got a vertical shift. We're going to go down 1, since this is minus 1. And I've got a phase shift. We're going to move left. Sorry, that should be right. This should be right. We're going to go right pi over 2. Okay, right pi over 2. Since this is minus, we're still going right over here. Okay, so for reference here, we would start at the origin, right, because that's our midline. And we are going to move this point down 1 unit and over pi over 2 units. Okay, so we're going to move down 1 unit over pi over 2. It's going to sit us right about here for our new starting point here. Okay, again, I have my vertical asymptotes. I'm going to plot those I'm going to go a half period one way and a half period the other way. Okay, and then I can just evenly space those out again based off of my period length. So since I shifted this vertical asymptote over here, this is going to be a half period, right? So this is going to be pi over 4, this distance here, pi over 4. So then at pi over 2, every pi over 2, I'm going to have a new vertical asymptote. So then we can go ahead and plot at each midpoint in between my vertical asymptotes, I'm going to have another midline intercept. My midline now is here at -1. -1, okay, it's going to be on this line right here. So I can just plot, again, 2 points within one of my intervals. So I'm going to pick this interval right here, and I'll pick points of pi over 3 and 2 pi over 3, since I have some nice reference points here, reference lines. So I'll get negative 1.9 and negative 0.13. So these are going to be points here and here roughly. And I'm just going to copy those over to all of my intervals. Okay, so we can see here I'm just copying this shape of my points. And then from here, guys, we just go ahead and make our curve. Okay, make our curve and then make sure we finish out the entire interval. So we're going to have just this half of a tangent curve here starting at 0, and at 3 pi over 2, we're going to come back this way with another half a tangent curve. All right, last example here. We got another sine function. We're in degrees this time. So we've got an amplitude of 1.5, a period of 360 degrees divided by 1. So that's going to be 360 degrees. We've got a phase shift. We're going to move up 1.5 units. And now for that's our vertical shift. For my phase shift, we're going to move left 30 degrees. Okay, so we're going left this time 30 degrees. So again, what does sine of x look like? Okay, the parent function looks something like this with our period at 360 degrees. We've got our starting point here at the origin. But however, that starting point is going to move up 1.5 units and over 30 degrees. So see how this has moved up up 1.5 units and over 30 degrees. Now we're starting right here. Okay, so my midline now is going to be right there. All right, we have just shifted our midline up 1.5 units. So now every 360 degrees, I've got a midline intercept, I know that. And then every half of that, I'll have another midline intercept because I know sine starts at the midline, goes up, comes back down, crosses the midline right here, and then comes down and then back up to the midline. So I've got effectively 3 midline intercepts for each period. So again, so every 180 degrees then I would have another midline intercept since my period is 360 degrees. Now in between each one of these, we are going to have a max or a minimum value. And we know that if this is my starting point right here, we're going to move up first. So this will be a maximum. And then when we come back down, we'll hit a minimum, back up to a maximum. And from here, guys, make sure we go back to negative 300 degrees. So I'd come down since I know I came from being up here above the midline. So I'll come down to a minimum and then back up to a maximum at 3. Right? And then we can go ahead and connect our lines with a nice smooth curve. And that would be that, okay? So keep in mind, guys, my phase shifts are affecting my range, okay? My phase shifts and my amplitude changes are affecting my range. So just keep that in mind if you're ever asked to define, say, domain and range for any of these. That is what affects range the most for these sine and cosine, is going to be my amplitude as well as my vertical shifts. All right, so that's it for this video, guys. I know it's kind of a longer one, but good luck with your practice.